All right, this is factoring polynomials. The first day is just a review of factoring polynomials. So if it looks familiar, it's because we've done this before. And much of this you did also in Algebra 1 and Geometry. All right, but we're doing it again. Okay, so this is the most commonly missed one is GCF factoring. It's because it's something we overlook. So this problem, people want to do like x plus 2x times 3, but it's not. There is a common factor, and it's only a common factor. So there's an x in both of them, so that's what makes it a common factor. There is something that's in both terms, right? This is two terms. So you take an x out. When you take an x out of x squared, that leaves an x. Remember, you're subtracting exponents. Remember, if you don't see an exponent, there's an invisible one, so it's 2 minus 1, leaving it 1. And when I take an x out of 6x, I just leave a 6. And that's it. That's the answer. Once you have no exponents on here, you cannot factor any further. All right? All right, that's it. That's the answer. Look at this one. This time I have a number and a variable in common. The biggest number that goes into 10 and 25 is 5. And both terms have an x in them, so I take an x out. So 10 divided by 5 is 2. Take an x out of x squared leaves an x. Negative 25 divided by 5 is negative 5. Take the x out, and that's it. That is GCF factoring. Part 2, difference of squares. That's when you're given a perfect square minus a perfect square. It has to be a minus, right? And this is related to that conjugate. If you remember the conjugate, there's a plus b, a minus b. When you multiply them together, you get this side. But now I'm giving you the left side. You're going to give me the right side. So here, there's a So x squared is a perfect square. 100 is a perfect square. Square root of 100 is 10. X minus 10, x plus 10. So if you don't know your perfect squares, just check it. Just put this in the calculator. 6 square root of 100. What is that equal to? That's equal to 10. That lets you know that 100 is a perfect square. And it breaks up into 10, negative 10, and positive 10. Okay, this one. Now, 64 and 144 are perfect squares. But let's take out a common factor first. Okay, let's take out a common factor. There's a common factor of 16. So I'm taking 16 out of both. 64 divided by 16 is 4. And 144 divided by 16 is 9. I still have perfect squares. 4 is a perfect square. 4 is 2 to the second power. 9 is a perfect square. That's 3 to the second power. So that's going to be 2x minus 3 and 2x plus 3. All right, that's it. Moving on. Basic trinomial factoring. Basic trinomial factoring. You've done this. Many of us are very good at this. All right, this is just a reminder. So what are the factors of negative 120 that combine to make negative 2? That'll be negative 12, positive 10. Negative 12 times 10 is negative 120. Negative 12 plus 10 is negative 2. Okay, so that's just going to be x minus 12 and x plus 10. That's all I'm looking for. Stop there. Don't go any further. That's the answer. All we're doing is factoring. We're just factoring. We're not solving. We're only factoring. All right, here. There's a common factor, right? All of these are a multiple of 5, so I'm going to take a 5 out. So the easiest thing to do is check to see if the smallest number is the common factor. Check to see if the smallest number is common factor. Fairly frequently, if it's a one-digit number, it might be a common factor. So I'll take a 5 out. So that's going to give me x squared minus 11x plus, what is that, 28? All right, now, so we're going to ignore the 5 when we factor this part. We're ignoring the 5 when we are factoring the trinomial. What are the factors of 28 that combine to make negative 11? Well, 7 times 4 is 28, but 7 plus 4 is positive 11. We can make them both negative. Negative 7 times negative 4 is positive 28. Negative 7 plus negative 4 is negative 11. So that's it. So x minus 7, x minus 4. And that's it. And this is where we have a leading coefficient. So in this one, there was a leading coefficient, but it was a common factor and it was removed. And the trinomial we ended up factoring did not have a leading coefficient. And this one doesn't have a leading coefficient. Leading coefficient is a number in front of the x squared term. All right, so in this example, we have 2x squared plus 7x plus 3. So we do this. We multiply 2 times 3 and get 6. What are the factors of 6 to combine to make 7? That's going to be 1 and 6. Right? 1 times 6 is 6. 1 plus 6 is 7. So we do x plus 1 over 2. That's the weird part. We divide by the leading coefficient. And x plus 6 over 2. Okay? Now, if it cannot be reduced, like this 1/2 can't be reduced, you're just going to go ahead and bring that 1 forward. Bring the 2 forward. That gives me 2x plus 1. Now the 6 over 2 can be reduced, and you just reduce that, plus 3. That's it. And the next one. This one has a common factor of 2. Take that out. So that's 10x squared plus x minus 2. Multiply 10 times negative 2. That'll be negative 20. What are the factors of negative 20 to combine to make 1? So we are not using the original first term. We're not using the original leading coefficient. We took out a common factor of 2. We're now using 10 as the leading coefficient. Okay? So it's 10 times negative 2, not 20 times negative 4. All right, what are the factors of negative 20 to combine to make 1? That'll be 5 and negative 4. 5 times negative 4 is negative 20. 5 plus negative 4 is 1. So that works. This 2, you just copy it, just coming for the right. X, and you're going to divide by the new leading coefficient of 10. So it's x plus 5 over 10. And x minus 4 over 10. Reduce the fractions. So that's x plus 1/2. And x minus 2/5. Bring out the bring out the denominator. So it's 2x plus 1 and 5x minus 2. And that's the answer. And that's the end of the video.